Hi everyone. Given the following conditional statement, if the angles are complementary, then they add up to 90 degrees. We're going to write, label, and explain why the statement is true or false for each of the three statements: converse, inverse, and contrapositive. So basically, here's our statement. If the angles are complementary, then they add up to 90 degrees. And I call that the if, then, then, and it's written or labeled as if P, then Q. All right. Now, the converse basically is you're switching the hypothesis part of our original statement, this part with this part. So the converse, I wrote if the angles add up to 90, which is this part, then they are complementary. So basically all I did is I switched my P and my Q. So this would be if Q, then P. Now the inverse goes with the conditional statement. So always kind of goes like that. The inverse goes with the conditional statement. And I remember they both start with I's. And I mean by they go with it, meaning that they have the nots in them. So all you're doing is copying down the if-then statement and adding the not. So if the angles are not complementary, then they do not add up to 90 degrees. All you're doing is taking your PQ and you're writing not, that's a tilde sign, not P, if not P, then not Q. All right? And the contrapositive always goes with the converse. They both start with C's, so these two always go together when you're talking about the not. So we have, you just write this statement down and then add the not part. So we're taking this statement and putting the not in front of it. So we're saying if not Q, then not P. We also have to state if these are true or false. So we know this is true. If the angles add up to 90 degrees and they're complementary, this is true. If they're not complementary, then they're definitely not going to add up to 90, so that's true. And this one is true as well. Since they're true both ways, we can call this a biconditional. Since they're true both ways, this is true and this one's true. And I can go P if and only if Q. Let me put that. Or you could say Q if and only P. And that's because both are true. All of this is true. All right, let's look at a biconditional now. An angle with a measure between 90 degrees and 100 degrees is called obtuse. We're going to rewrite it as a biconditional statement. And I already did it. So basically, it says for the conditional, if an angle has a measure between 90 degrees and 180 degrees, then it is called obtuse. So if, then. If P, then Q. I just put the if in front and reworded it a little bit. And then it is called, so I just put it right in there. Okay. Now the converse is where you change the beginning portion or the hypotenuse with the conclusion. So that would be if Q then P. So basically the biconditional means, since both of these are true, we can write this as P if and only if Q, or we could write it as Q if and only if P, what we kind of talked about before. So you could write it either way. Usually you write it the beginning like they have with the hypotenuse. So usually when they ask you to write a biconditional, write it this way. But you could write it this way as well. All right? It's true because both the hypotenuse and the hypothesis, and the conclusion are true. Now, I want to go over real quick this nice format. So a conditional, if then, joins two statements, usually the hypothesis and the conclusion, in the form of if P, then Q. So that would be P, and you write this arrow, Q. And here's an example. If a polygon has four sides, then it is a quadrilateral. The converse is you just switch the P's and Q's. So P is replaced with Q, and Q is replaced with P. So you're just going to write Q, if Q, then P. And all they did was switch the statements. So if a polygon is a quadrilateral, then it has four sides. So that you just switch the sides there. Now again, the inverse always goes with the conditional. I remember that because the conditional is if, then, and they both start with I. So you just negate whatever this is. So both the P and the Q are negated. So you take this and negate both. If not P, then not Q. And you just take this statement and add the not. Does not have four sides. Is not quadrilateral. And finally, the contrapositive always goes with the converse. And I know those are the same because they both start with C. So you're just taking this one and negating it. So the contrapositive, okay, so we're going to go back to the original. So the P is replaced with the Q, and the Q is replaced with the P. Q replaced with the P, and they're both negated. So basically all you're doing is you're taking this one and negating it, just like we did earlier. Not P. All right, and it's a tilde. So all I'm doing is I'm taking this problem, this statement, and putting the not in it. And they both start with C's there. Let's see if they're true or false. If a polygon has four sides, then it's a quadrilateral. That's true. Not necessarily true. A polygon can have four sides, but it doesn't have to. Yeah, then it is true. It's not equilateral, so that's true. If a polygon is quadrilateral, so that's true. If a polygon does not have four sides, then it's not a quadrilateral. That's true. And if a polygon is not a quadrilateral, then it doesn't have four sides, and that's true. So this could also be written as a biconditional, if and only if. And that's it. Thank you. Have a nice day. Bye-bye.